Hi to everyone. Today I would like to explain about stationary process as well as time average and ergodicity. The contents related to stationary process are first order stationary process, second order stationary process, Widesense stationary process and Strictsense stationary process. And one more topic is time averages as well as ergodicity. First, I will explain about the first order stationary process. What is meant by first order stationary process? The name itself tells that stationary. That means it is constant with respect to time. Since about we are having first order, the first order density function is constant with respect to time. Hence, the condition for this case is nothing but the first order density function small f(x) of x1 semicolon t1 is equal to small f(x) of x1 semicolon t1 plus delta t. Delta t is nothing but changing time. Even though the time is going to changing, now the first order density function is constant. Hence, it is named as the first order stationary process. So, thus the condition for the case of first order stationary process is nothing but its mean value is constant. Mean is indicated with E of x of t. Mean is also known as the expected value. For the case of a random process x of t, E is the expected value, E of x of t is constant. So, thus for the case of first order stationary process, the condition is nothing but its mean is constant. Next, consider the case of the second order stationary process. The name itself tells that it is a second order. That means it's a second order known as joint density function is constant with respect to time. That means even though the time is going to changing, the density function does not change. So, the condition for the case of this one is second order density function indicated as small f(x) of x1 comma x2 semicolon t1 comma t2. Here we are going to define the random process x of t at two different times t1 as well as t2. Hence, this is the notation for the second order density function. This is equal to the f(x) of x1 comma x2 semicolon t1 plus delta t comma t2 plus delta t. Here you can observe that the t1 is shifted by the amount of delta t as well as t2 also shifted by the amount delta t. Even though the time is going to changing, now the corresponding density function is having the same value. Hence, it is known as the second order stationary process. For this case, the condition is Rx of t comma t plus tau. It is known as the autocorrelation function. Shortly known as simply ACF. Autocorrelation function ACF is indicated with Rx of t comma t plus tau, that is equal to E of x of t into x of t plus tau. Of course, where tau is nothing but the difference time t2 minus t1. So, that is why here this is equal to simply Rx of tau only. The autocorrelation function does not depend upon the time t, and it is a function of tau only. Tau is nothing but it is the difference of the time t2 minus t1. t1 may change or t2 may change, but tau is nothing but a constant value. That's why for the case of second order stationary process, the autocorrelation function is constant. The indication of Rx of tau means it is a constant only. So, this is about the second order stationary process. Then coming to the Widesense stationary process. Here you can observe the word wide. In this case, both the first order as well as the second order stationary process conditions are going to be applicable. That's why both first order and second order stationary process as well as the density functions are does not changing with respect to time. That means the both conditions are, the first one is E of x of t is constant. That means mean is constant. And second condition is the autocorrelation function Rxx of t comma t plus tau is equal to Rxx of tau. So this is the first condition and this is the second condition which have to be satisfied by the Widesense stationary process. Then coming to the joint Widesense stationary process. In the previous case, you have seen that only one random process have taken. For that mean as well as the autocorrelation function have defined, those two are constant in previous case. But now it is the joint Widesense stationary process. Now here we are selecting two random processes x of t as well as y of t. Then what are the conditions? Those two functions to become jointly Widesense stationary. For individual random process, two conditions are there. Now for the two random processes, total we are having the 5 conditions. Those are, the first one is nothing but the mean should be constant. That means E of x of t should be constant and E of y of t should be constant. This is for the case of the random process x of t and this is for the case of the random process y of t. And the third condition is nothing but its corresponding autocorrelation function. There is a function of Rxx of tau only. This is for the random process x of t and this is for the random process y of t. Now can define one more function, that is nothing but the cross correlation function. Here in these two cases you can observe that both are having here x only and here both are having y. That means this is the simply ACF of x of t and this is the ACF of y of t. Here you can observe that x and y both they have included. That means this is known as the cross correlation function. And shortly known as the CCF. And this is the CCF of both x of t as well as the y of t. So now for the case of the jointly WSS, that is the Widesense stationary process, there are 5 conditions are there. That means both the mean should be constant, both the autocorrelation function should be constant. Along with that, the fifth one is nothing but cross correlation function is also constant. Totally they have to satisfy the 5 conditions. Then only can tell that both x of t and y of t are jointly Widesense stationary. And the next one is nth order or Strictsense stationary process. It is shortly known as the SSS. For the case of first order density function is constant for the case of the stationary process and second order density function is constant for the second order stationary process. For the case of WSS, both first order and second order density functions are constant with respect to time. Now it is the nth order, means the nth order density function is constant with respect to time. What is the nth order density function? Small f x of x1 comma x2 so on xn semicolon t1 comma t2 so on tn. This is the notation for the nth order density function. That should be equal to the fx of x1 comma x2 so on xn semicolon t1 plus delta t. Now here you can observe that t1 is shifted by the amount delta t and t2 is also shifted by the amount delta t. So on tn is shifted by the amount delta t. For all the values of t1, t2, so on tn, all these are shifted by the amount delta t, but still it is equal to the corresponding nth order joint density function. Hence it is known as the nth order stationary process or SSS process, that means Strictsense stationary process. Since it is going to satisfying that nth order density function is constant, so thus all the parameters like mean, earlier we have seen the mean or expected value, that means E of x of t, this should be constant. Autocorrelation function Rxx of t comma t plus tau should be constant and cross correlation function is there. Rxy of t comma t plus tau should be constant. Still, what are the parameters are there? All are going to be constant. Hence the name Strictsense stationary process. That means all the parameters are constant with respect to time. So these are the classifications of the stationary process. First order, second order, WSS as well as the triple S. Coming to the next topic, that is a time average. Earlier we have seen the general average is also known as the statistical average. Now here, in the case of random process, by including time t, we are going to calculate the average. That average is known as the time average. Statistical average is indicated with E of x of t. Now, what is the time average? It is indicated as, the time average function is indicated as A of x of t. Statistical average, we are going to writing as E of x of t. Now, the time average is indicated as, instead of E, simply indicated as A. And A of x of t is also indicated as simply small x bar. In the case of the statistical average, it is indicated as capital X bar. Now it is the small x bar. Then what's the formula for this one? Limit t tends to infinity 1 by 2t, integral minus t to t x of t into dt. For the case of statistical average, without this t, we are going to calculating only by using this. But now here, we are going to including time t. So that's why this is the formula for the case of the time average function. Once again, see that the time average is indicated as A of x of t. And the next one is time mean square function. The notation for this one is A of x square of t. Here it is nothing but the average or mean. Now this is the mean square. That means we have to square the random process. Then for that we are going to calculate in the mean value. Now that mean value is nothing but time mean or time average. Hence it is indicated as A of x square of t. In general, statistical mean square is indicated as E of x square of t. But now it is the time mean square function. Hence it is indicated as A of x square of t. That is equal to limit t tends to infinity 1 by 2t integral minus t to t x square of t dt. If it is simply average or mean, we are writing x of t. Hence it is a mean square, we are writing x square of t. That is only simple difference. This is about the time mean square function. Next one is time autocorrelation function. The time autocorrelation function is indicated as Rxx of tau. Statistical autocorrelation function is indicated as capital R, capital XX of tau. Now this is the time autocorrelation function. This is capital R, small xx of tau. That is equal to A of x of t into x of t plus tau. In the case of statistical autocorrelation function, instead of A, we are writing as E. Now here, we have to represent as A. The respective formula is limit t tends to infinity 1 by 2t integral minus t to t x of t into x of t plus tau into dt. Here, what are the function we are having? Simply have to replace inside the integration, then we are going to getting the respective time function. In the previous case, we have calculated A of x of t. Simply here written as x of t only. And A of x square of t, we have indicated here as x square of t. Now it is the A of x of t into x of t plus tau. So indicate here as x of t into x of t plus tau. So this is nothing but the time autocorrelation function. And the next one is time cross correlation function. It is indicated as Rxy of tau. Let us see here. We are having autocorrelation function is same random process we are going to taking at two different times. Hence it is Rxx. Now here it is the cross correlation function. Two different random process we are going to taking. That's why this is Rxy of tau is equal to limit t tends to infinity 1 by 2t integral minus t to t x of t. Now see here, the second one is nothing but in the previous case is x only. Now here we are having y of t plus tau is equal to dt. So this is nothing but the time cross correlation function. So that's how seen about the time average as well as time mean square function, time autocorrelation function and time cross correlation function. The statistical parameter instead of E simply represent as A, and in the formula you have to include the time t here. Okay. Then coming to the next topic, ergodicity or ergodic theorem. Earlier you have seen about the time average, that is say A of x of t. So if the time averages are equal to the statistical averages or ensemble averages, then that corresponding is known as the ergodic theorem. Time average is nothing but A of x of t and statistical average is nothing but E of x of t. Like that all the functions, all the time parameters should be equal to the statistical parameters or ensemble, that is known as the ergodic theorem. That principle is known as the ergodicity. Then what is meant by ergodic process? A random process which is going to satisfying the ergodic theorem is known as the ergodic process. Suppose small x is there, which is nothing but indicated as a random variable, and its corresponding mean value is nothing but small x bar, and this should be equal to the capital X bar. This is the time average and this is the statistical average. It is going to satisfying that, then that is known as the ergodic process. Then one more is there known as the joint ergodic process. Suppose if you are going to consider two random process x of t and y of t, then what are the conditions for the case of joint ergodic process? The first one is nothing but their corresponding mean values. That means small x bar should be equal to the capital X bar and small y bar should be equal to the capital Y bar. That means here the mean values are same. That is the time mean value is equal to the statistical mean value. Then one more condition is respect to cross correlation function. This is Rxx of tau is equal to Rxx of tau. So this is nothing but the time ACF and this is the statistical ACF. In the notation, these are the lowercase letters and here uppercase letters. Anyhow, in this case, the time autocorrelation function is equal to the statistical autocorrelation function of x of t. And here, time autocorrelation function is equal to the statistical autocorrelation function of y of t. So this is for the case of the random process y of t and this is for the case of the random process x of t. And these two are individual correlation functions known as the autocorrelation functions. Now if you combine both, then we are defining the cross correlation function. This is the time cross correlation function is equal to the statistical cross correlation function because we are having the xy. Okay. So anyhow, the second condition is nothing but the time correlation functions are equal to the statistical correlation functions. That's why it is known as the joint ergodic process. Okay. So once again see that in the case of ergodic process or ergodic theorem, the time averages are equal to the statistical averages or ensemble averages. Types of ergodic process. Based on which parameters we are going to taking, there are different types of ergodic process out there. In that, the first one is mean ergodic process. Here, E of x of t is nothing but the statistical mean, which is also indicated as capital X bar. That is equal to the time mean, that is A of x of t or small x bar. If the time mean is equal to the statistical mean, then that respective process is known as the mean ergodic random process. Next one is autocorrelation ergodic process. The autocorrelation function is indicated as Rxx of tau. Now here the time ACF, this is nothing but the time ACF, indicated as A of x of t into x of t plus tau, that is equal to the E of x of t into x of t plus tau. This is known as the statistical ACF. If these two are equal, then respective process is known as the autocorrelation ergodic process. In short, it is also indicated as Rxx of tau is equal to Rxx of tau. Here this is nothing but lowercase letters and here these two are the uppercase letters, making the difference between the, this is a time ACF and this is the statistical ACF. So thus for the case of autocorrelation ergodic process, time ACF is equal to the statistical ACF. And the next one is cross correlation ergodic process. Here we are taking cross correlation, that's why we have to define two random processes, x of t as well as y of t. For that, the time cross correlation function is indicated as A of x of t into y of t plus tau. This is known as the time cross correlation function. Here you can see that we are having time autocorrelation function both consisting of x only. But now in this case, one is x of t, other one is nothing but y of t plus tau. So this entire is nothing but the time cross correlation function. This is equal to the statistical cross correlation function, that is E of x of t into y of t plus tau. This is a condition for the case of the cross correlation ergodic process. That means statistical cross correlation function should be equal to the time cross correlation function. In short, it is also indicated as Rxy of tau is equal to R capital Xy of tau. Like that, there are three types of ergodic process are there, like mean ergodic process, autocorrelation ergodic process, cross correlation ergodic process. In this video, I have explained about the stationary random process as well as the time average and ergodic process, what is ergodic theorem, as well as the different types of ergodic process. Thanks to all of you.